Gamma-ray bursts. Gamma-ray bursts are the most powerful explosions known in the universe. They occur when massive stars collapse into black holes or when neutron stars collide, releasing more energy in seconds than the sun will emit in its lifetime. The first burst was detected in 1967 by US military satellites designed to monitor nuclear tests. A typical burst lasts from milliseconds to minutes and can be followed by afterglows across multiple wavelengths. If a burst occurred within a few thousand light-years and was aimed directly at Earth, it could strip away the planet's ozone layer and expose life to lethal radiation. Some researchers have suggested that past mass extinctions may have been caused by such events. The closest known candidates for potential gamma-ray bursts are located in the Milky Way's outer regions, but none are currently aligned toward Earth. Solar superflares. Solar superflares are massive eruptions on the surface of a star that release hundreds of times more energy than typical solar flares. In 1859, the most powerful known solar storm, called the Carrington event, disrupted telegraph systems worldwide and created auroras visible near the equator. A modern event of that scale could disable satellites, destroy power grids, and cause trillions of dollars in damage. Observations from the Kepler Space Telescope have shown that similar stars to the Sun experience superflares approximately once every few thousand years. In 2012, a coronal mass ejection nearly as strong as the Carrington event missed Earth by just 9 days. Scientists continue to monitor the Sun's magnetic cycles to estimate the likelihood of another such event, but current models cannot predict them accurately. Asteroid impacts. Asteroids larger than 1 kilometer in diameter possess enough energy to cause global effects upon impact. The most famous example is the Chicxulub event, which struck the Yucatan Peninsula 66 million years ago and contributed to the extinction of the dinosaurs. The explosion released energy equivalent to billions of nuclear bombs, throwing dust and aerosols into the atmosphere and blocking sunlight for years. NASA's Near-Earth Object Program currently tracks over 30,000 asteroids that pass within 50 million kilometers of Earth. In 2013, a 20-meter-wide meteor exploded above Chelyabinsk, Russia, injuring more than 1,500 people. To prevent future catastrophes, space agencies are testing deflection strategies such as NASA's DART mission, which successfully altered an asteroid's orbit in 2022. Despite these measures, thousands of smaller objects remain undetected in near-Earth space. Magnetic pole reversal. Earth's magnetic field has flipped many times in its history, with the last full reversal occurring about 780,000 years ago. During a reversal, the magnetic poles gradually weaken and swap positions, a process that can take thousands of years. The magnetic field shields the planet from solar and cosmic radiation, and a weakened field could increase radiation exposure at the surface. Studies of ancient lava flows and ocean sediments have revealed that reversals happen irregularly, averaging every few 100,000 years. Satellite data show that the field's strength has been decreasing for the past 2 centuries, especially over the South Atlantic anomaly. While scientists agree that a reversal is not imminent, the gradual weakening continues to be monitored by observatories worldwide. The long-term consequences remain uncertain. Rogue black holes. Rogue black holes are black holes that drift through space after being ejected from their original galaxies. These objects are invisible, except for the gravitational effects they produce. In 2022, astronomers using the Hubble Space Telescope identified a possible rogue black hole moving at approximately 160,000 kilometers per hour through the Milky Way. If one were to pass near the solar system, its gravity could disrupt planetary orbits or even eject planets entirely. Computer simulations suggest that billions of rogue black holes may exist in the universe, formed from stellar collisions or gravitational slingshots. Although the probability of a direct encounter is extremely low, their existence demonstrates that the solar system moves through an environment filled with massive, unseen objects, whose paths remain largely unknown.